Hello, think we are now live. Welcome if you're here. Feel free to say hi in the chat so I know you're listening, you're ready to go. We're going to start shortly. I'll just give everyone a chance to say hello. And we've got disguised quadratics as the topic we're going to look at today. So welcome if you're here. It's been a long term, I'm sure, for everyone settling back at school. So we're going to power through with a really good topic today. We're going to be looking at disguised quadratics, which comes up at A level throughout year 12 and 13 in not only the pure maths, but also some of the mechanics and the applied side of the course as well. So welcome if you're here, feel free to say hello. I have got the chat open so I can answer any questions as we go, and it'll be lovely to hear from you all. So I'll shortly share my screen and we'll work through some problems on quadratics today. And then I'll talk a little bit about SnapRevise as well. Welcome, hi, thanks for the message. I'm about to get started. I hope you're doing well. And we're nearly there. We're nearly at a bit of a break now. Hi, welcome. Thanks for messaging in the chat, guys. I hope you're all doing well. And hopefully this is a topic that will be really beneficial to you. Obviously, quadratics is something we've seen. Welcome. Hi, thanks for the messages. This is great. Quadratics is something we've done all throughout school, and obviously something that builds and builds at A level. Hi, excellent. Right, it's lovely to see your messages in. I'm going to share my screen now so we can actually get started, but please feel free to ask any questions as we go. And yeah, great topic to be getting on with. Really good for those that have just started A level and those that are in year 13. Lovely. Thanks for the comments, guys. We're going to get started here, so hopefully you can see what I'm about to share with you. Here we go. So we're looking at disguised quadratics today. Can everybody see my PowerPoint? I'm just sharing it, making it full screen. And I'm just going to adjust it so that I can write on it for you there. Lovely, welcome. Right, I know a lot of people are facing mock exams, tests. This has been a really unusual, unprecedented year, guys. And I feel for everyone that's at school at the moment, it has been really tough because a lot of schools have been putting assessments in place. Quadratics is a great topic to look at. This is a topic that obviously you're supposed to be familiar with from GCSE, but it is hard at A level. It does get disguised. It does come up in weird, quirky ways. So what I'm going to do, I'm going to talk a little bit about the session and SnapRevise, and then I'm going to get started with some really good problems today. Feel free to answer and ask any questions as we go. And we'll get started. Here we go. So I'm Max. I'm head of maths at SnapRevise, and I did a maths degree a few years ago now, and I've been teaching A-level maths for the last 4 years. And yeah, I do a lot of web classes each week for SnapRevise on A-level content, and I'll talk a little bit about that later. Here we go. So we're going to look at today recognizing a quadratic equation, even in a disguised context. So this is key to pure maths, but it comes up in year 12 and 13, and it doesn't just come up in the core side of the course anymore, although it like the pure maths side of the course, although it largely does. This is a skill that runs throughout the whole A level. So what I'm going to do is I'm going to look at recognizing when there's this disguised element of a quadratic in the questions, and also looking at how we can find the number of solutions. And then we'll also solve some problems. So there's a great deal of exam style questions we're going to work through today. Please feel free to submit answers in the chat, and also questions if you need me to clarify anything. Right, I think we'll get started. So just to begin with, I'm going to talk about the key things we should kind of know, or at least recognize from GCSE. So, or before, any maths we've done before. I'm just going to flip my laptop around so I can write on it. Here we go. So this comes up early on. Obviously, different exam boards cover this content in different ways. So the chapters and stuff vary. I believe for Edexcel, it's quite an early chapter, but then obviously it appears throughout the course. So the key things we should get familiar with is this idea of a discriminant, which we recognize as b squared minus 4ac. So hopefully you've seen that before. And if that is greater than 0, that tells us that the quadratic has 2 solutions. Okay, and essentially greater than 0, I mean if it's positive. Lovely, excellent. If it's equal to 0, and I'm sure those of you that have covered this will recognize this idea, it has 1 solution. So this discriminant, this part of the quadratic formula, tells us how many solutions it has. Lovely, well done guys, thanks for the comments as well. And then if it has less than 0, this is when you type it into your calculator and it says math error and it starts having a problem. Or if you've got a fancy calculator, it says some weird thing with imaginary solutions. This has no real solutions because you're trying to square root a negative. So this is when there's no real solutions. Okay, and I'm shorthanding that, but hopefully we follow and we recognize this. So no, so the discriminant, no, good question there in the chat. That's referred to as the coefficient. The discriminant is this specific bit of the quadratic formula. But please do ask, clarify anything if you're not sure. Great question. So one way we could solve this that hopefully we're very familiar with is this idea of factorizing. So we've been doing this throughout school, and it's one that factorizes hopefully as follows. And what we get is that's equal to 0. And then from that, we need to interpret what the solutions are. So some people go, I kind of know what to do with this one. That means x equals -3. That will solve the original problem. You're absolutely right. But what you're essentially doing when you factorize is saying this quadratic is this thing times this thing, and it needs to equal 0. So when can two things multiply to make 0? When one of them or both are equal to 0. So when is that bracket equal to 0, x plus 3? Well, when x is -3, that bracket will be 0. 0 times anything is 0. So this is the harder one that people often mess up, but it doesn't need to be any harder because it's the same process. So if you're saying, well, when is 3x minus 2 equal to 0? If you rearrange that, nice linear equation there, it's when x is 2/3. That also solves the quadratics. Okay, I will try and address questions as I go. I'll whiz through this quickly and then I'll keep an eye on the chat. Hopefully everyone's familiar at least with the idea of factorizing. The other process we've got is the quadratic formula, which is this fancy formula here that a lot of Hollywood films like to use and make the student look like a genius for being able to recall this formula. But it's actually something that's on the GCSE and we should be getting used to by now. It's a little bit long-winded, a little bit tedious, but it does the job and solves the quadratic. So b squared, so 7 squared minus 4 times, and a, b, and c are the coefficients of the quadratic, 3, 7, and -6. 4 times 3 times -6, all over 2 times a, which would be 2 times 3. And if you plug that in, you will also get your answers of x equals -3 or 2/3. Lovely. Okay, brilliant, great work, guys. So this all looks familiar to a lot of people. So what I'm going to do for the majority of this session, I'll whiz through some exam questions, talk about how to approach them and how to answer them. And then at the end, talk a little bit about snap revise, and we'll go from there. So completing the square. This is a technique a lot of people don't like, and it actually comes up in quite a few places throughout the course. So those of you that have done the circles topic or chapter, you'll see that you need this not only for quadratics, but being able to deal with that scenario. So what we do is we need to get it in the form where the coefficient of x squared is 1. So we can take the 3 out as a factor. And then what we do is we kind of half the coefficient of x, make it a double bracket, minus that scenario squared. And for this one, this is probably quite a tricky way of doing this question, given that it factorizes nicely, but it still gets you the correct answer. So when you solve and rearrange, x plus 7 over 6 is equal to plus or minus 11 over 6. And I will be looking at this in more detail as we go, but this is hopefully a process we've at least seen before, even though it looks a little bit nasty. So lots of different ways to deal with quadratics. Obviously, if you've got a ClassWiz calculator or one of the calculators that solves quadratics just by you plugging it in, that's not a problem. That's brilliant. What we're going to focus on today is actually noticing where there's a hidden quadratic, because sometimes problems can really throw us off and we think, yeah, this looks fine, or this looks really tricky. I can't see where it wants me to go. So all the exam boards, whether you're with AQA, Edexcel or OCR, this topic is fundamental to the course. And since the A-levels were reformed back in 2017, there's a lot more overlap, like all the different boards cover the same stuff now. So this is really crucial. Completing the square, it's a good question. People don't like it because it feels too much of a process. It's easy to go wrong. There's fractions. It is actually really important that you can complete the square. Not only does it allow us to solve the quadratics, does anyone know what completing the square also allows us to find? There is another application graphically. Completing the square allows us to think of it as a graph transformation and find turning points of the quadratic. That can be really useful in mechanics. So maximums and minimums. Excellent. Thanks, guys. Lovely comments in the chat. So you might still think, yeah, but I still don't really like it. That's fine, but it is a process we need to get on board with, and we can look for little tricks on how to do this. And absolutely, you need it for circles. You need to be able to complete the square to deal with circles. So what we're going to do today is have a little look at quadratics that are a little bit hidden. And I'm going to move on to talk about a process we deal with for this. So here's a nice example. This looks like a polynomial where the highest power is 6. And you might think, well, I haven't really dealt with that. My calculator can't really handle those sort of polynomials nicely. This is actually a sneaky disguised quadratic question. So what we basically do is we can show that a given equation is a quadratic using what we would call a substitution. Okay, so we can sub something in. We can make a clever little substitution, and it will boil down to a quadratic scenario. So we let y equal some function of x. But basically, I'll do this as an example. Can anyone suggest what we could replace or tidy up this equation with to make it look more like a quadratic? I've got a something to the 6, 3 times that same something cubed, minus 14 is 0. Brilliant for the suggestions. Thank you, guys. Yeah, excellent. You could let y, we could call y x cubed. And then we could start to see, right, if I make y x cubed, this starts to look a little bit like a quadratic. Brilliant, because if we think about it, x cubed squared is x to the 6. So that would be y squared. So what we'd have, superb, thanks for the suggestions there. This is lovely. Right, so let's go. So what we're going to end up with, if we make that little substitution, we get y squared equals 3y minus 14. That bit remains unaffected. And now we're looking at a scenario that looks a lot more like a quadratic that we're used to dealing with. And again, it doesn't necessarily factorize nicely. So what we're going to need to do is from here, solve it using the formula if we think it's not going to factorize well, or complete the square, or however we want to do it. Let's plug it into the formula and check we're good, because, and feel free to work ahead of me on this, guys. This is a great example. The thing I also want to mention for the quadratic formula, because it's so easy to get anything wrong with this formula because there's a lot to plug in. Be really careful in your calculator that whenever you're squaring a number, if it's negative, you use brackets. Because even though you can just rely on your calculator, people still mess up really commonly with this. And probably the biggest mistake, even in a maths degree, all the way through with maths, it's always a minus sign that messes someone up. So that's what you've got to look out for on the calculator. We could use factorizing if it factorizes nicely. I'm going to sort of help you out here and hint that it doesn't. But yeah, certainly try that first. And if you think there's no way I'm going to be able to factorize that easily, then you've got to look for an alternative method. But yeah, excellent. Great question. No, exactly. Not every equation can be factorized, which is why we need these, and actually more often than not, they don't, which is why we need these other skills. So what we've got is, if I now solve that, we're going to get y equals to 2.53 or minus 5.53. And hopefully you agree with me, you've tried that maybe, and that makes sense. The problem is we haven't actually solved exactly what it asked. So I've solved it for y, I've solved it for my substitution. How do I deal with that to actually solve it for x? Because this problem was a scenario involving x. So what do I do here? Can anyone suggest sort of how I get from my value of y to give me my value of x? And we've got to be careful. Like, let's look back at what we set up in the first instance. We said that y is equal to x cubed. So that's great, but it's still this undoing step that is very easy to just do slightly wrong. And we don't want to get the question wrong having done all that work. So yes, we need to carefully put it back in. Well done, good comment. So what we need to do is that's equal to x cubed. I don't want x cubed, I want x. So I have to cube root both of those values. So if y equals that or that, if I cube root, x is equal to the cube root of y, which again, you'll do in your calculator. And the two values you'll get are 1.36 or minus 1.77. Now, be careful. A lot of people think, can you do the cube root of a negative? You absolutely can. You can't square root a negative, but a negative cube rooted is a negative. That does work. Okay, brilliant. Hopefully that's all nice and clear, but we're going to carry on with some slightly more involved questions as well. Thanks for all the comments there. That was lovely. I'm glad we're following along, but please do tell me if you want to go over anything, you need anything re-explained, or you want to just double check. That would be brilliant. Right, let's keep going. So we can determine the number of solutions of a disguised quadratic by finding what we mentioned earlier, by finding the thing with a special name, finding the discriminant. Okay, lovely, excellent. So that thing tells us if it solves, and if it solves, how many solutions there are. Now, again, this looks really kind of tricky to start with. We might not even be straight away recognizing this as a quadratic. So we've got to think, well, what do I do here? How do I deal with this as a quadratic? So can anyone recommend a substitution we could make? What could I replace as y that will make this a lot nicer and a lot easier to see or recognize as a quadratic? It does look a lot more involved than what we just saw, so don't worry and don't panic if you can't see it. But again, look at what's going on here and look at what's going on here. And hopefully we can think, right, well, y could be equal to x minus 2 to the power of 5. Because that would mean y squared is x minus 2 to the 5 to the 10. Oh, sorry, to the 2, which would be the same as x minus 2 to the 10. Hopefully everyone's happy when you do a power of a power, you multiply. Okay, so that's the substitution we make. And as soon as we put that in, it becomes a lot nicer looking as a quadratic. So if I put that in, then I can replace all this with y squared. So what I'm going to get here is I'm going to get, and well done if you've just submitted this as a suggestion, 4y squared minus 12 lots of what we suggested was y, and then the 9 is unaffected. And that's a lot easier to look at. It's a lot easier to deal with. Yes, absolutely. So the discriminant, the point of the discriminant, which we're going to do here, the discriminant is the b squared minus 4ac thing. And hopefully you recognize that as a sort of fundamental part of the quadratic formula. And what it basically says is it tells us if the quadratic formula is going to work or not. So if it comes out as a positive number, square root a positive number, perfect. We get a plus and a minus answer. You get two answers when you square root a positive number. Square root of 25 is 5 or minus 5. So if it comes out as positive when we do b squared minus 4ac, there's potential, there's two answers. If it comes out as 0, that bit of the formula disappears and we just get minus b over 2a. So there'll only be one answer. If that comes out as negative, if the discriminant is less than 0 and it's negative, you can't square root a negative. So the quadratic doesn't have any solutions. So when someone was asking earlier, oh, what does it always factorize? No, but sometimes there are actually also no solutions. It doesn't always necessarily solve. And it's the discriminant that will tell us whether it does or whether it doesn't, and how many solutions. So what I can do is I can look at the discriminant of this quadratic and see what's going on. So I'm going to do b squared. So b is the minus 12, a is the 4, and c is the 9. B squared minus 4 times 4 times 9. Okay, and that will come out as 144 minus 144. And well done if you've already said it. That equals to 0. So that tells us there is only one real root. There's only one answer to this because the quadratic discriminant that we found comes out as 0. Okay, so what I've done here is I've done b squared minus 4ac. So if you're unclear on where that's come from, that's a, that's b, and that's c. And b squared minus 4ac is this, minus 12 squared minus 4 times a, which was 4, times c, which is 9. That comes out as 144 minus 144, which is 0. So that tells us that there's one real root. And the way you'd find that real root, they haven't actually asked us here, they've just asked us how many solutions are there. The way you'd find that is you'd go, okay, so the one real solution here, whatever we get when we, when we rearrange this, it will be our value for y that we sub into the quadratic formula. So when we solve this quadratic, to put it back in terms of x, we know that x minus 2 is equal to the fifth root of that solution, and then we add 2. Okay, but as I said, this question wasn't asking us to solve it. It just asked us how many roots there are, and all you have to do is use the discriminant. Okay, excellent. So I'm going to move on. Let's look at this one. Who has come across exponentials or the exponential function? And it's majorly topical this year, understanding mathematical modeling and rates, growth rates and rates of change and models. I think there's not been, really a better time to get to grips with the A-level maths content quickly with everything that's going on in the world. There's a lot of applications of what we're seeing, not only in pure maths, but also in kind of the statistics, those that have done hypothesis testing. You can imagine in this day and age how important testing is and mathematical models are in our day-to-day life. And, for the way things are going, how things are going to improve, it's all relying on the mathematics. But anyway, getting back to the problem, exponentials, if you haven't seen them, I'll talk this question through. Feel free to comment and ask. But this is a later topic that begins to bring in some quadratics. So what we've got is we've got e to the 2x. E is an irrational number, a bit like pi. It's an important number for exponential models. And what we have is here, I'm going to let y equal e to the x. Because what we'll have is e to the x squared is obviously e to the 2x because you times the powers. So that would be like y squared. Okay, lovely. So what we're going to have here is we're going to have y squared plus y minus 6 equals 0. So what we're doing with this is we're thinking, can I solve that quadratic? So give it a go and let me know in the chat if you think, right, I can solve that quadratic. I know how to factorize. I could use the formula or complete the square, whatever you want to do. How do we solve it? So you might have been able to factorize it. Please do mention in the chat if you know how to factorize it. This one does actually factorize nicely. Good. So what we've got is y minus 2, y plus 3. And well done if you got that. That's brilliant. Is equal to 0. So what we've got here is we can solve for y. What are the solutions for y for this question? So hopefully we all agree that it factorizes like that. Obviously, you can use your formula as well. Well done. Thanks for those answers. That's lovely. Y equals to 2 or minus 3. And obviously then we put our solution back into what we made the substitution. So e to the x equals to 2 or to minus 3. Now, if you haven't done exponentials before, that's probably the furthest you could get with this, but there's one more little step with this. So what we can do with that is to solve that, to undo an exponential. Does anyone know the process we need to use? Does anyone know what the inverse function of an exponential is? And if you haven't met it, exactly, well done. It's logarithms, the natural log. And on your calculator, you might have seen a button that says ln, natural log. That is what this is. So if you take the natural log of both sides, you get x equals to natural log of 2. And if you try and do ln of minus 3, there'll be an error. It's not defined, it doesn't work. So that is the only answer. So that's natural log. That isn't something that appears at GCSE. So if you haven't done this topic yet, it is in year 12 maths, it is in year 12, but you do it as a whole topic or chapter. As you get towards the end of that topic and chapter, what you start to see is these quadratics start emerging again, and you need to be familiar with, right, it's a disguised quadratic, let me sort that out, and then we'll put it back into an exponential and logs scenario. And yes, you could work that out as a decimal on your calculator. In pure mathematics, what they often like for the exams is just leave it as an exact answer, in which case that is it. If they say to 3SF or to 2DP, absolutely put it in your calculator and see what it is using the S to D button. That's brilliant, right? So excellent. As a little checkpoint, if you could just let me know in the chat if you've been following along, how you're feeling with this. And obviously, if there's bits you haven't met before, then no worries, give me an idea. So if you're absolutely fine with this, you're quite confident with this content, a 1, 2, if it's kind of okay, but there's bits to look over, and 3, hopefully I haven't super confused anyone, but I appreciate the honesty and appreciate anyone telling me if they've got any questions. So that's great. Lovely. So good. Yeah, it's a good topic. It's challenging. And just coming back to a question someone had a minute ago about why it isn't -3. You can't take logs of a negative number. So again, that's within that chapter. But if you plugged it in your calculator, ln -3, it wouldn't work. So sometimes there are other broader scenarios where the quadratic doesn't work. For example, if you had a quadratic and it related to times or lengths and you got a negative answer, you would know to ignore that because you can't have a negative length. So it's one of those sort of scenarios. Right. This one is a little bit involved, so we're going to go through this together and see how we get on. And then we've got a few more questions of this style, but please do keep asking questions or submitting your answers as we go. Brilliant questions though, guys. Thanks again for all the engagement in the chat. I appreciate it's a Sunday into probably one of the longest terms that it's felt like at school of December. It's been quite a full-on year in lots of different ways, so really well done. But we're going to keep going because we've got a few more problems to get through. So this one, can anyone suggest here how I can make this look like a quadratic? This is perhaps not as obvious as some of the others. So this looks like it's almost like a linear equation, and then they've thrown in like a square root bit, a power of a half. Can anyone suggest how I could make a little substitution to turn this into a quadratic? Good suggestions. This power of a half doesn't mean you half it. It doesn't mean it's half x or 0.5x. It means you square root it. So another way of writing this question, and this is obviously within the index laws topic, you could write it like this. And that might actually help you think about how we substitute it. Yeah, good. A few different ways. And well done, guys. Thanks for the... Yeah, this looks a little bit more involved. It's not. It's the same process. We just make a substitution. And actually, what often is a good way of doing it is looking at what the x bit is, the bit that isn't being squared. So if I let y equal x to the half, or root x, are we happy that y squared would just be x? Because if y is the square root of x, y squared is x. Does that make sense? Yeah, really good suggestions. And it's once we've got used to this, once we've done this question before, it is actually the same every time. So I think the honest thing with A-level maths is they do look hard. When you look at this question and you haven't done it before, there's all these P's and Q's and R's and all kind of integers and different words, and it looks very confusing. But really, all A-level maths is about is having a breadth of practice so that when you've seen that style of question before, it doesn't phase you. Looks a little bit wordy, looks a little bit involved, but it's not a problem. So here we go. We get cracking with this. That's our substitution. Let y equal square root of x. Then that would mean y squared is x. So what we've got here, this would then become y squared minus 6y plus 2. Now, a far more conventional looking equation. It looks more like a quadratic that we're used to. So Right, y, good. You want me to re-explain this bit? That's absolutely fine. If y is root x, if we're choosing to let this bit be y, the square root of x squared is x. So that would make this bit y squared. So we've turned it into this equation. Hopefully that makes sense. Is that clear to everyone? And that was probably the hard bit of getting started on this, is if you choose to make this bit y, then when you square it, when you square the square root, you just get the thing. So that would mean y squared is actually x. Okay, so hopefully that's a little bit clearer. But that is actually the bit of the question that makes it confusing for people. So that's fine. So we've now arrived at this quadratic. Then what we're going to do is we're going to go, excellent, good, no worries. Please do ask if I need to clarify anything. That's great. So this bit will be the next bit of the question that people don't like. Put it in this form. You could actually just use the quadratic formula. That's fine. I would actually think, let's do this by completing the square, because it will put it in that form. And it's a good bit of practice of completing the square. So to complete the square on this quadratic, we would get y minus 3 all squared. Then I have to minus off 3 squared. Because when you have this sneaky double bracket here, y minus 3, y minus 3, that gives us y squared minus 6y plus 9. I don't want plus 9, so I'm going to minus the 9 off. But I do want positive 2. So what I'm going to get here is the completing the square form of that quadratic. For those that have done it, looks like this. Okay. Now, to solve this, you can just rearrange it. So if I add 7 to both sides, and then if I want to get y on its own, I'm going to square root both sides. Y minus 3 equals, now remember, any positive number, there are 2 square roots. There's plus or minus root 7, which obviously isn't a nice number. And then what we're going to do is add the 3 across. Brilliant answer. I think that is actually correct, but I'm going to get there. And I appreciate some people might still be struggling with this. So please do ask me, those that are where I'm at, if I need to clarify anything. So I add the 3 and I get this solution, 3 plus minus square root 7. If you're thinking, what is going on? How did he just do that? Obviously, the quadratic formula would work as well, but you want to leave it in surds. You don't want to put it as a decimal. And that's what the answers will be. 3 plus root 7 or 3 minus root 7. Now that is the solution for y. We're not solving this for y, we're solving it for x. So from this answer, I've got to think, well, how do I get x? Now remember, y is equal to the square root of x. So if I actually want x, I need to square my values of y. Okay. So what I need to do is, if y equals that, then x equals the values we've got squared, which equals 3 plus root 7 squared, or the other answer, which is 3 minus root 7 squared. Now, don't forget, that's a sneaky double bracket. That's 3 plus root 7, 3 plus root 7. So to expand that, 3 times 3, you're going to get 9, plus 3 root 7, plus 3 root 7, and root 7 times root 7 is 7. So plus 7, tidy it all up, and your answer is 16 plus 6 root 7. So well done to anyone in the chat that already got this. And the other way is, remembering the minus version. Very similar process though, guys, for this bit. And I'm happy to go back over anything. I'll get this written down. If anyone's got any questions, I'll double check it. That'll come out as 9 minus 3 root 7 minus 3 root 7 plus 7 again, because minus root 7 times minus root 7 is positive 7, because a minus times a minus is a plus. And that will come out as 16 minus 6 root 7. Now let's just look back at what the question asked in this form. So the answer is 16 plus or minus 6 root 7. And for those that really clearly explained it in the chat, 16 would be P, Q would be 6, and 7 would be R. So 6 marks, it does feel very full on. And actually, right, good question. We had brilliant questions coming in throughout that. I'm just going to have a little check. Really, the easiest way is to do this by using a substitution, just so it's a bit clearer. Some calculators, some questions will lend themselves to other methods as well. If you're presented with a graph, sometimes there's other ways around it. And it sort of all tests your sort of mathematical fluency with these topics. But in general, when these questions appear, there should be some underlying quadratic that's okay to solve. To be honest, this is quite a typical A-level question, and it's quite easy with the maths to think, well, that's too hard. I don't like that. That's not going to come up. It does come up. But once you've done enough practice of this, the ideas don't change. And I think really being prepared for A-level exams, it's very different to GCSEs. You have to do enough breadth of practice. It's so easy with maths to practice the questions you like or the questions you're good at. Oh, well, I'm even better at something I was really good at. You've got to get kind of practicing things you don't like, because once you can kind of nail those topics, you've covered the course. You've got to grips with the content. You can't shy away from these things, but you do obviously need to ask the question and make sure things are clear, because absolutely, I completely agree with all of you. There are a lot of steps there and a lot of places you could easily go wrong. And it wouldn't be a major mistake, but it would be really difficult to see that mistake. So we have to go really sort of carefully and methodically through it. But yeah, another great question. Anything needs clarified, please do ask. I'm going to go on to another example now. So I'm going to just move this on. This question here again. So the first thing we want to be looking at is how is there a quadratic there? How can I see a quadratic? And again, if you haven't done the exponential chapter and the a to the power of x kind of scenario, finishing this question off might be a bit tricky at this point, but I am going to work through all of it. So can anyone make a suggestion on what substitution I could make here that will allow me to write this more clearly as a quadratic? And don't worry if you're still not completely sure. Right, a really good question. You do need to be able to complete the square. For a lot of topics, there are ways around it. Like I said this earlier, for turning points and stuff, your calculator will do that. But as I mentioned, as you go through the course, topics like circles, where you need to find the equation of the circle, you have to use completing the square, and the calculator doesn't really help you there. So I hope that answers the question. But again, that's another topic you've just got to get a little bit of practice on and think, I need to be able to do this. And if you can cut corners and not have to do it, that's fine. Brilliant. Some suggestions coming in. I'm going to let y equal to 7 to the power of x. Okay, superb suggestions there, guys. Now, also the question said 2dp, so they don't want exact answers. They do want you to plug it in and get a decimal answer. But let's deal with the scenario to start with. So the quadratic will become, y squared minus 4y plus 3 equals 0. Okay, is everyone clear on how that's come about? So remember, 7 to the 2x is absolutely the same thing as 7 to the x to the 2. And I've called 7 to the x y. So it's y to the 2, it's y squared. Hopefully that's all clear. Okay, lovely. So if we need any specific bits clarified, I mean, that's probably the hardest bit to do. And I completely appreciate just this concept of doing a substitution is challenging. Once you get it looking like a quadratic, if you're confident with quadratics, it's the same level of difficulty. But actually making it look like that is the challenge a lot of the time. So what we're going to do here is we've got this quadratic, and hopefully when it looks like that, we know how to solve it. This one does in fact factorize as well. Y minus 3, y minus 1 equal to 0. Okay, and what we have here is that will mean that y equals 3 or 1. So what that means is that 7 to the power of x equals 3 or 7 to the power of x equals 1. And you might now be thinking, how does that work? How can 7 to the power of something be 3? And if you've seen this chapter, if you've seen exponentials, you'll know how to do it. But again, this comes back to a topic called logarithms. So 7 to the power of 1 is 7, and 7 to the power of 0 is 1. So the number's got to be a decimal. It's got to be somewhere between 0 and 1. This bit, you might go, well, I know how to do that. That bit is when x equals 0, because I know my index laws. It's this one that's a little bit trickier to solve. So the way that we do that is we use this thing called a logarithm, log base 7. So x is equal to log base 7 of y. And again, if you haven't met this topic in school or you haven't seen it before, you won't know how to do this because this is its own topic. But you can see how quadratics comes up throughout the course. So log base 7 of 3, if you type that in your calculator, will be 0.56. And if you did log base 7 of 1, it would come out as 0. So your two answers are 0, which is an answer, or 0.56. Those two answers will solve the problem. Okay, lovely. Great suggestions there. And really good work. That's lovely. So let's keep going. I'm mindful of the time because obviously I do want to explain about our other web classes and what we offer in terms of continued support for the A-level throughout for pure statistics and mechanics. I'm just going to move this on. So deriving quadratics, let's have a little look. Now I think I'll do another example of one that involves a bit of trigonometry. Who has met trigonometry at A-level? So obviously at GCSE, it's much the same sort of standard. Again, on all boards, you do the kind of SOHCAHTOA part, and then you also do sine and cosine rule. But this bit is quite full on. When you meet the trig at A-level, it gets quite involved. And we have these things called trig identities, so trigonometric identities. And what we find is that sine squared plus cos squared is identically equal to 1. So for any value of x or theta, if you plug it in, it will always equal 1. So if you've seen that before, you'll recognize that importance of that within the topic. And what that means is we can replace sine squared with a rearrangement of this identity. And the 3-line equals is an identically equal. It means it's always true. So what we can do is we can replace it as 2 lots of 1 minus cos squared theta, and that is equal to cos theta minus 1. And if I now expand and rearrange, I get 2 minus 2 cos squared theta. And feel free, if you have seen this before, to work ahead of me. And at the same time, if this looks really confusing or difficult, please do ask. Right, I'm going to rearrange this and see what I get. And I'm going to get I'm going to bring it all to the right-hand side, all over here, because I prefer positive quadratics to deal with. So what I'd get is 2 cos squared theta plus cos theta minus 3. Is everyone happy with that rearrangement? Equals to 0. So that is just expanding it out, bring it all to one side. I chose to bring it to the right because then actually it looked like a nicer sort of scenario. And now we do need to make a substitution. So yeah, absolutely. This bit here, I just rearranged this thing. Thanks for whoever's explained that. That is absolutely right. This is something we learn in trigonometry. If I just minus cos squared across, 1 minus cos squared is the same as sine squared. And that's what I plugged in. Thank you. Excellent. So my substitution I'm going to make now, feel free to suggest, let y equal, I'm going to let y equal cos of theta. Because what that will mean is cos squared will obviously be y squared. So the quadratic I'll get is 2y squared plus y minus 3 equals to 0. And again, this is one that factorizes, but you can also use quadratic formula or any other technique to solve it for y. So 2y plus 3, y minus 1 equals 0. So that tells us that y is either equal to 1 or minus 3 over 2. So what that actually means is that cos theta equals to minus 3 over 2 or 1. Oops, or 1. And I don't want cos theta, I want I want theta rather. So how do I undo cos? Does anyone know how to do that? So for those that have done trig, I mean, you've kind of done this at GCSE as well, hopefully, but to get the angle out of cos, you do cos inverse, arc cos. So the button on the calculator where you press shift and cos, that's how it undoes it. And what you'll get is this bit won't have any solutions, but when you do inverse cos of 1, you'll get theta is equal to 0 or 360 degrees. And they are allowable values because it's an or equal to. So you have two answers there for theta. So what was really a kind of trig heavy problem was ultimately a quadratic. So this is how the topics are going to sort of seamlessly overlap and stuff as we go forward. So hopefully that's been kind of insightful for those that haven't met these topics yet, how important quadratics are. And although these little skills we brush over at the start, I understand that, you know, the first few weeks of the A-level, it feels like we're just going over GCSE stuff. I want to get on with something new. It's just to really emphasize how important these skills are as we go forward. But that's great. And well done if you followed that. And thanks for everyone that's been asking the questions as we go. That's brilliant. Obviously, these web classes we're doing on YouTube, we do regular web classes on every topic of the A-level every single week on the Snap Revise platform. So I'm going to talk about that shortly. 90, good question. 90 wouldn't solve this problem because cos of 90 isn't these values. Cos of 90 is 0, but a good question there. So don't be careful that you're whether you're using cos or sine, because it's easy to mix up the two. But excellent question. So here's another one we can have a little look at. Again, if you haven't done logarithms before, this might look a little bit involved. So I'll quickly whiz through this. So for part A, I'll rearrange this across. So log 3. So to show where this comes from, we're given that y equals 3x squared, and this really hinges on you understanding logs and having covered logs before. If I replace y in this equation with what we've got, y has been told as 3x squared, then using log rules, that breaks up as log base 3 of 3 plus log base 3 of x squared. And then that sort of tidies up to 1 plus, and by the power law, that comes down to log 3 of x. I am getting conscious of the fact that some people might not have done this, so I don't want to kind of confuse you. But again, this then goes into dealing with a quadratic scenario, but the question is a bit more scaffolded. What I'm going to do, I think I'm going to move on because there's a good amount of questions that I would like to talk through, but I don't want to kind of confuse anyone there. And I'm kind of conscious of the time. Just in general, on the bits we've covered, if you could let me know in the chat for the ones we did, just a 1, 2, or a 3, just to give me an idea of the kind of pace of that and how you found it, that would be brilliant. And as I said, it does kind of build throughout the whole A-level, not just year 12, but also year 13, and actually not just the pure maths. So some of it I know is a little bit confusing if you haven't done it, obviously. But for those that have sort of met this before, hopefully at least the quadratic part of that is very familiar, and you know, okay, yeah, I know how to factorize, or I know I need a bit more practice on completing the square and so on. So even if you're kind of in the middle, you hopefully can appreciate from this class how important quadratics are. And actually the hardest step for a lot of people is probably spotting how the disguised bit is working, how to make the substitution. So please don't shy away from these questions. Do make sure you do a good bit of practice. Yeah, absolutely. Apart from logs or exponentials, if you haven't done them, that's absolutely understandable. But that was great. So well done with that. So what we've looked at is recognizing when an equation could be a hidden quadratic, how to solve the number of solutions, that's basically by the discriminant, and also rewriting them as quadratics, like applying the substitution and solving it. So if you have any questions, keep them coming in the chat. What I'm going to do now is quickly talk you a little bit through Snap Revise, what we have to offer, and the web classes and resources we have available. So I'm going to stop sharing that there, but I still have the chat open so I can see your messages and answer any questions as we go. I'm just going to share, hopefully you can all see the following screen. So this is the Snap Revise website, if you haven't been onto it before. And just to talk you through some of the things we do, these are the web classes. So we run web classes and I do them every week for year 12 and 13 content. So for example, tomorrow I'm looking at logarithms actually as a year 12 class. And then I do a drop-in straight after where if you've got any homework questions, tests coming up, I'm happy to go through anything that you're struggling with and really tailor it to help you out. And that's something we offer as part of the service with weekly web classes followed by drop-ins. So year 13, I do web classes and drop-ins for on a Wednesday. And there's also a kind of backlog of previous recordings that if you want to go on and have a look at them and watch them through and go through the guided content, that's for all topics in A-level maths. So hopefully, yes, so we do all differentiation. We do the whole course basically spread over the year. So there's a year 12 set of lessons and classes and year 13, and we go through the course fully. So that's part of the platform that's there if you're interested. And also in terms of what else Snap Revise has to offer, lots of superb tailor-made diagnostic quizzes, revision resources, revision packs, exam questions on every aspect of the A-level. So you can do a quick diagnostic quiz, which then jumps you to a video that you can work through. And after that, you can kind of look through key aspects of the questions and follow it up with an exam pack. So all of the exam packs on every topic, you have an easy, medium, hard question, and then really clear solutions that are perfectly in line with what the exam boards would do. So it's an excellent, superb, tailor-made resource. The other thing I would just advise, because I know a lot of people, there's a lot out there for maths practice. There's lots of good websites. There's no sort of shortage of questions. The key thing to realise is as the A-level changed in June, in 2017 rather, some of the sites that are out there, it's tailored more for the old A-level. This is sort of bang up to date with key bits of the syllabus really pinpointed in every aspect of the questioning and the design, and it's constantly being updated and being kept on top of, especially with everything that's going on at the moment. So really worth bearing that in mind. So there's the web classes, there's loads of really lovely kind of revision materials as well. So if I go back, obviously you can all explore this yourself, but just to introduce you to what is available. And yeah, if you go through any of the topics, mock papers, mock questions, all designed perfectly to the different exam boards. So hopefully that's given you a bit of an insight. I'll just stop sharing that shortly and return to the PowerPoint. So hopefully you can see this again. So thanks again to everyone for taking part so well today. For 2021, for the new year, we've obviously got more live sessions coming up on YouTube, but then obviously the weekly web classes and drop-ins run alongside all the content that's being put on the Snap Revise platform. And this is obviously for the other subjects as well. I'm only talking from the kind of maths side of it. So if you've enjoyed this, you found this worthwhile, please do set a reminder on YouTube. And hopefully it'd be great to see you guys at the next session. Thanks so much for the engagement in the chat and all the work there. And the other thing to just let you know is there is a quick one-time kind of discount. So if you are interested in signing up, there's this discount code that expires at midnight tonight, and it will give you £10 off your first month. So if you would like to try it out, make a note of that. And that would be great. And you can use that for the first month. But as I said, we will have other sessions coming up very soon. So in the new year, keep an eye out for that. Set the reminders and obviously subscribe if you haven't. But that's great. And I wish everyone the best of luck. Please do have a bit of a rest as well, because I know it's been a really full-on term for everyone. And if you're doing A-level maths, you're doing a very difficult A-level. So well done, but keep going. And it all comes with the practice. But do ask the questions and do be as proactive as you have been today. That was brilliant. So I think that brings me to the end there. I'm going to stop sharing that. So keep well and take care. Thanks again to everyone. It's been lovely working alongside you, and hopefully that's been useful. Have a good rest of the year. And as I said, keep safe and hopefully see you at one of these sessions in the new year. That's lovely. Take care, guys. Thanks.